Hey guys, welcome back to another installment in this DIY CNC build series. As you can see here, I've reached another major milestone in the project. We've pretty much now got the entire frame assembled, aside from the Z-axis. It's taken a lot of patience and hard work to get to this point, but as you can see, this thing looks very sturdy and it's going to be a very capable machine. So I've got all the brackets on for the bearings for the ball screws, motor brackets on the back as well on all corners. As I say, the gantry's all squared up perfectly 90 degrees, and the only thing I've got to do now is get the linear rails on and then use this as a jig to line those up. So this will be where we get to by the end of this video today. Appreciate all the comments and feedback on the last video. I'm glad you guys enjoyed it. I'm going to go with a long format again because it seems to be helpful, and yeah, let's go and build it. Alright guys, so here we are with all the parts that will be required to use in this video. Everything here is for the X-axis. We do obviously have the linear rails which I have stored over there, and these parts here will be in a future video where we're working on the Z-axis. So what I have here are the gantry side plates. This is obviously the large gantry back plate, which these bolt to the side. These ones here are the Y-axis motor brackets, and as you can see, I've already measured and marked out these pieces. These here are the rear Y-axis ball screw bearing mounts. These are the front Y-axis ball screw bearing mounts, and these ones here are the Y-axis bearing blocks. So these ones sit on top of the linear rails. These bolt to the bearings underneath, and then obviously you slide that whole piece onto the linear rail. So the parts we're working on now are a bit smaller, apart from this one of course, which is the biggest piece of the lot. But once you've got this Y-axis frame together, that's probably the hardest bit in my opinion. And maybe the second hardest bit to that is getting the gantry completely parallel on each side to this. But that should be made easy by using the gantry as a jig. So the past couple of days I've been quite busy again creating these technical drawings, so I'll zoom in for you again like I did before and I'll talk you through those. You'll probably recognize this drawing from the previous video, which was obviously for the Y-axis cross sections. But you can see I've updated them a little bit, so I've made it a bit clearer. I've added the units up here so there's no sort of confusion over that. I've also made some notes on each of the drawings where I'm specifying whether the holes are actually holes or threads. So in a case here, for example, we know both of those are M8 threads because I've specified it there. These holes are obviously just holes because there's no thread. We were just passing the bolt through. But what I've done also is updated each design with a technical reference so that in the CSV file that most of you will have downloaded, I'm going to actually update those. So on the materials parts, I'll have a technical reference in a separate column so that you know which of the physical parts relates to the technical drawings, which should make it easier for those that want to do the same thing here. So the next one we've got here is the front ball screw bearing mount, which is this part. As you can see, again, they're 1:1 scale. I've already gone ahead and done the measurements and hole punching last night. I wanted to sort of do that ahead of time because one thing I don't want to do in these videos is keep repeating myself. So if this is the first video of mine you're seeing and you think, well, oh, he hasn't explained how to do this very well, please go and watch the previous videos because I did explain how you can measure and mark and do all that stuff. I don't want to keep repeating myself because ultimately it will drag out the videos. So you can see quite clearly here it's easy to read the measurements and correlate them to the parts. There was a couple of issues where, for example, this part I've got here in the CAD is specified at 50 millimeters. However, the part being provided is actually 51 millimeters. So wherever you get your parts from, there's always some cutting tolerances. In this case, I'm 1 millimeter long in the width. So in that case, all I wanted to make sure of is that the side I'm referencing as my 0 point is flush with the front surface of the CNC in this case, because you don't want any overhangs. It wouldn't be an actual issue. It's just if you want it to look a nice sort of finish. In that case, just always make sure you reference from the same side, whichever side is the most important. Next part we've got here is very similar, but in this case it's the rear ball screw bearing block. So I've done that as well, marked those out already. This is the Y-axis bearing blocks that I talked about here. So again, 1:1 scale, easy to reference. So you can see this one has a side view associated with it also. So this side of the bearing block bolts to the large gantry side plates, which then connects the whole machine to the linear rails. And these holes on the top, as I said, they will be used to bolt to the actual bearings themselves. The next one we've got here are the Y-axis motor brackets. It's the same for the left and the right. There's no threads or anything here, so they're just they're a mirror of each other. As you can see again, already marked out these holes. It took me a good few hours to do that and check them. I'm also going to triple check them before I drill the holes, just to make sure that everything's correct. These actually have some additional holes here, as you can see. And what they're for, on the rear ball screw bearing bracket, there's some holes on the side here, and they actually are used to bolt this piece to that piece, along with these holes which bolt into the ends of the long Y-axis pieces. So I tried to add in holes there just to add some rigidity and stop any movement, particularly with those huge Y-axis motors. There is one hole on this part that could present a few challenges. This is a 30mm diameter hole. That obviously has to be there for the motor to be able to couple to the thread. I'm going to try and tackle that on my practice piece first. I'm going to use one of those larger hole saw bits. I'm not sure how well that'll work at this stage, but I'll get to it. There's a few other things we could do. One thing you could potentially do is just drill lots of smaller holes all the way around and just sort of break it away piece by piece, and then you could file the inside out. So if you don't have the capabilities to drill a huge hole, it's still not impossible. So as I said, I'll get to that when we are machining the parts in a little bit, and I'll talk you through that one. This one here is the large gantry side plates. This is a 1:2 scale because it's such a large part, again, it wouldn't fit on the A4 sheet. Again, with this is quite a straightforward one. We're dealing with everything in parallel really with these holes, all measured widths apart here, and you can see I've specified the hole sizes. This one actually has a mistake on it in terms of my labelling. So I've said here that these are M8 threads, they're actually M8 holes. So I'll go and update that before this video is sort of released, or before these are released. Yeah, I mean, it's quite straightforward. As you can see here, you can assume all the holes that appear to be the same size are the same size. I like to keep these drawings nice and clean. So I could have gone through here and put 8 mil, 8 mil, 8 mil, but it's just, it clutters the drawing. So unless I've specified a hole to be a different size, you can assume they are the same. Like these are a lot smaller, but I've said there it's an M5 hole, and that's measured a hole. I've got these measured a thread, but they're actually holes. But on the other designs, if I show you here, you can see I've done that there, where I've specified that they are threads and they are holes. So that just clears that up. And the reason I've done that is because these are M8 threads, but you'll actually want to drill a 7mm hole to create the thread. I've kept the holes true to size in the CAD drawing. Just be mindful that when you go to create these, if you're doing an M8 thread, you're not going to use an M8 or an 8mm bit to do the hole. So just be mindful of that. The second one here is the side view of this large gantry backplate, because obviously these are M8 threads which I've specified here, and these here are M8 holes because we're going to put large bolts. We're going to have large bolts that just pass through these holes but thread into these, so that'll hold all that together. So there we go. Hopefully that gives you a brief sort of explanation as to what we'll be doing in this video. As I said, I've already marked and measured everything out. I don't want to repeat myself there, so what I'll do now is I'll probably just run a time-lapse type of thing. You can see me machining all these parts. If you have any questions at all, please leave them in the comments. I'm happy to answer those. And yeah, as I said, not much left to do. It's getting there. It's going to really start to look like a machine once this part is done. We have that gantry on the top. Exciting stuff, so let's go and machine these parts. Okay, so like I said earlier, one of the things I'm going to have to do here is drill this 30mm diameter hole. This is for the motors to couple to the ball screws, and I'm going to attempt this here using the step down bit. The largest bit size I've got here at the top is 32mm, and the one below that is 30mm, so I only need to go up to this top one here. So I'm going to do that now. I'm going to take my time, plenty of oil, and hopefully this will work. Alright guys, so after an hour or so of attempting to use the step down bit, it just doesn't have what it takes to make it through this with this particular drill. It just takes too long. I'd be there for another hour or so. So what I've done is I've gone and bought this metal cutting hole saw bit. This is a 30mm bit. It's a great brand. This bit is made to do stuff like this, and it should make easy work of this aluminium. Again, I'm still going to go slow, take my time, plenty of oil. Hopefully this one works out well. Obviously I've lost my center hole as a guide here, which is a bit of a shame, but I've lined it up as best as I can to try and keep that center hole in place. The alignment of this isn't too critical, as I left enough room either side for the coupler, so there's a good sort of 5mm either side of where the coupler will be, so even if it's a mil or two off, it's not going to be the end of the world. Okay, so there we go. I've managed to successfully measure and machine all these smaller parts here. I'm still yet to do the side plates and the gantry back plate. What I'm going to focus on first is getting the rest of these holes done on the y-axis frame. If you remember before, I said there were some extra holes on the sides here for a lot of these plates to bolt to. So for example, this rear plate here, this has 4 holes at the bottom which bolt into the back end of this long y-axis piece. So there we go. The next step, I'm going to use these to mark out the holes, drill the holes, and then I'll get on to the side plates and the back plate. So this plate here, as I said before, is going to mount directly here, so it bolts onto the cross section and the long y-axis piece as well. So that is going to bolt there, so I can use the drill bit just like before to mark out the holes, and then obviously that ball screw bearing will bolt on through these holes at the top. So these are going to be threaded, these holes are not, but the holes behind them are obviously going to be tapped for this to bolt to. One thing I'm going to do here as well is to not rely on the wood for a flat surface. So I'm going to raise the machine up completely on some of the other parts that I have. So there we go, I've now got the entire machine resting on these, so I know that when I'm making my markings I can be truly square here on the bottom and on the sides. You can see there, that's perfect. So all I'd want to do, just like before, use a couple of blocks here to keep everything nice and square, and then simply make our markings using the drill bit. As you can see, we've got 4 markings on there. So just like before, I'm going to do this on every corner. There's also some on the back here. This is the front end of the machine, so these don't have any plates on the front, but on the rear end what we have is something like this, and then this back plate which holds the motors comes on over the side like this, so there'll be additional holes on the back. So what I'm actually going to do here for these parts is drill them out by hand with the power drill. The main reason being that the cross section pieces in particular are obviously so long that it'd be difficult to do them under the pillar drill anyway. I could swivel the pillar drill on the edge of a bench, for example, and kind of have it as a standing pillar drill. As long as you're careful, you can drill these relatively straight by hand. They're only sort of short bolts anyway, so even if you're not perfect, it's still okay. That'll make the process a bit quicker too, because it means I haven't got to take all this apart. Remember, once again, an important thing, these are M8 holes, M8 threads, so this needs to be a 7mm hole. It's very easy to make the mistake of thinking, oh yeah, that's an M8, chuck an 8mm bit in and you're going to blast away your thread straight away. So 7mm bit in each of those, then an 8mm tap, and that should do the job. I'm then going to bolt this in place so that I can put the second part on here on the back, so that everything's nice and lined up for me to make the holes for that part. I've also been making a note of which part I used to reference the measurements for each one. That way when I go to assemble them, I know which I've got: front left, obviously, rear right, front right. That way I'll remember and everything will line up perfectly later on. Again, we're going to use a similar procedure here. Small pilot hole, swap the bit up to a larger size and go in. When drilling anything out by hand, it's often useful to use a piece of tape to indicate your stopping point. That way you can roughly measure up here how far you need to drill. Put your tape on, wrap it around your bit, and now we know exactly where we need to drill to and stop. That way you're not going to go too far or fall short when you come to do the thread. So with the holes drilled, we can then proceed to do the M8 tap, and you can also do this way, as long as the hole should guide it in nice and straight anyway. Just be careful to keep that as straight as possible, particularly on the way in. Don't forget to add a bit of oil, of course, and I'll bolt that on. I've also found a better way to apply the oil is to have a pot of oil and just dab it on with a paintbrush. It saves spilling a lot of oil, and oftentimes you just end up wasting it when you're pouring it on. So there we go, I've cleaned up and polished the corner plates here, they're all looking great. The linear rails I've put on top, but obviously they're not mounted down yet as I explained. So what I'll be doing next is working on the gantry side plates and the bearing blocks. So I need to get those two joined together. To do that I'm going to be using some clamps so that we can hold everything in place. And I'll grab those for you now and show you where we're at. Right, so as I said, what I've got are some bar clamps here. These are quite large, which will allow me to work and hold lots of these different large work pieces. All I've done here is taken the gantry side plate, as you can see, and I positioned it exactly how it's going to be mounted. So the good thing about using the clamps is you can use another object obviously to make sure you're all square, and when you are, simply just lock them together. Again, the reason clamps are going to be helpful when doing this here is because we know that everything is going to be square and 90 degrees, and then just like before, with everything held together, not moving, we can mark out our drill holes. This hole here goes right through this part, through the bearing block. I didn't originally intend for that hole to go right through, but I thought I'd do it anyway as there's no harm. And also, during this process, it's going to make creating these holes a lot more accurate, because like I said, I can push the bit straight through there, have the entire hole there as a guide for the bit, and just mark out those there very accurately. So the first two holes I'm going to do are the top one and the bottom one here. I'm then going to thread each of them, and this bolts from this side. So that bolts into the bearing blocks, which obviously then sit on the rails. The reason I'm doing those first is so that I can bolt them on, then take the clamps off, and then proceed to drill the other three holes. The reason I want to bolt it in place is so that, again, there is zero error when drilling out these holes. I'm going to actually start this off by hand, just so I can get a good guide. As I said, there's not going to be any slippage in these parts because these clamps are very strong. The torque of the drill isn't going to move those. Then I'm going to go ahead, take this back apart, complete the holes on the pillar drill, do the taps on these, come back, and then continue. As you can see, the drill bit just falls straight in. There's no force there at all. It's not moving anything, and I can just start to drill, not even putting much pressure. And that's going to start creating that guide hole for us. I'm going to do the same on the other side. So there we go, you only want to make a couple of marks. You don't want to go into the material necessarily. Now if we undo the clamps, take this one off. And there we go. You can see we've got our two guide holes now for me to go and continue on the pillar drill. As I said, I'm then going to come back, bolt those on in the orientation that they're required, in which this case is this way. And then I'll proceed to mark out the other holes and drill those all the way through on the pillar drill as well. So there we go, just drilled those outer two holes there. They line up perfectly. And now what I'm going to do is go ahead and do the threads in all of these holes. I'll probably start with the outer two and thread the others when the part is bolted together. That way you get a more accurate thread also. Remember, as I said, these are very long bolts here, so these will be approximately that deep into the part, obviously minus the cap head there. So we're going to have to thread pretty much all the way through with our tap. The side I'm going to be threading is this side, so I'm going to go ahead and do that now. Remember, these are M8s, so we want to have a 7mm hole tapped with an M8 tap. Similar to before, just apply a bit of oil with a brush and simply begin our tap. Might be useful to use a vise for this, but I'm doing it here, so I'm not going to use a vise. If you have a good bench vise, you're going to want to use that. One of the other things that I'm adding in here with the bolt is a split spring washer. Okay, so you can see here now that I have my 2 end bolts in and tightened up, and this is absolutely perfect. I'm very pleased with how this has turned out. I couldn't have been more accurate with that, I don't think, which is great because now I can drill out these other 3 holes using this as a guide, so I can't get those wrong really. And that's going to allow me to bolt these on very securely. What I'll do then is I'll do the exact same process on the other side, because obviously we have the other pieces as well. So I'll document that process now, and then we'll move on to the exciting part, which is getting the holes drilled here for bolting on that gantry backplate. And that's where this is going to really start to look great. There we go guys, so that's one of our gantry side plates successfully bolted to the bearing blocks. Honestly, I can't tell you how happy I am with how this one turned out. No pressure for the other side, right, because they've got to be practically identical. So now I'm going to go ahead and do the other one. And there we go. We have the second gantry side plate mounted to our bearing block. As you can see now we've got the 2 of them. So there are 4 additional holes to drill here for this part, which allows the gantry to move up and down the ball screw. So I'm going to add those from the drawings, make the holes. They're not threads, they're just holes because these actually have their own threads in them. So again, we'll be bolting from the back side through to these, which will hold that nicely. On the left plate, which will be this one, there's also another 30mm hole like we drilled out here. Now, this is probably going to be the most difficult hole to drill out of the entire project with the limited tools that I have. So this plate here is 10mm, and that was a job to do that, to be honest with you. I had to go sort of halfway through on the pillar drill, flip it around, go halfway through, and then finish it off with a power drill. So this is going to be challenging. I'm going to take my time. This is 20mm thick. This is heavy duty stuff. I'll do my best with it, get it as accurate as I can. The good thing about these holes is they serve no purpose other than to allow a coupler to sit in there so that the motor can connect with the ball screw. So if it's a bit of a messy hole, it's not that accurate, it's not the end of the world. So there we go. After I've done those, the next task will be to do our holes up here and on the opposing piece to mount that gantry backplate, which will be super exciting. So there we go, we now have these side plates both marked out and punched, ready to be drilled. They correlate to the drawings nicely. We've got 8mm holes running down the sides here to bolt into that big gantry back plate, and the rest of the holes here are going to be M5s for the motor brackets and the ball screw joint. So what we've got here is that center hole that I talked about, which is going to be 30mm, That could pose a challenge potentially, as I said, as it's got to make its way through 20mm plate, but we'll get to that in a minute. Right, so here we are again with the 30mm hole saw bit, and I need to create that hole here in the side plate, obviously for the X motor to connect to the X-axis ball screw. This is a very thick piece, it's 20mm thick, so this is probably going to take me quite a while. So what I'm going to do is go down as far as I can to the point where it's just struggling and it's sort of locking up. Like I said before, this is a low power pillar drill. Probably not designed really to do stuff like this. You'd want something very powerful if you wanted to keep going all the way through. But what I can do is get as far as I can on the one side, flip it over, go as far as I can on the other side, and then, as I said, finish the job with the power drill. That's all the tools I've got for this. I don't want to go spending a ton of money on a expensive power drill for now. I'll use what I've got and hopefully the result should be good. So I don't actually own a wall powered drill, but if you own one of them, that would be great for this. In my case here, this is all I've got. Still a very, very good drill, and it will do the job. It's just going to take a bit more effort. So I'm going to swap the bit onto here now and complete this. Also, to help us mess with the vise in particular, I found that it's often just handy to just do something like this. That way you haven't got to worry about too much mess getting on your bench. One thing I'll also say is that when you're doing this, particularly with high speed, the bit is going to get extremely hot. So make sure you don't burn yourself. And also when you're done with the bit, don't put it down on a wooden surface. Put it down on something metal, like the pillar drill surface here for example, because it could potentially start fire. And you'll see it, the bit actually starts to smoke, it gets so hot. To help with that, you can add oil, of course, which reduces friction and in turn reduces the heat generated. One thing I am going to do here is clamp this down, because what I don't want is the bit to spin and come flying at me. So I'll do the same on the other side as well. If you are going to be doing this with a handheld drill, you'll want to have multiple batteries on standby, because it's going to blast through your batteries, because it's requiring a lot of energy to do this. So there we go, we made it through. This is going to be extremely hot. As I said before, loosen the bit, don't touch it, and just put it aside for a while. Let it cool down, and from there we can clean this part up and we have our hole. That should be one of the most difficult parts to drill, so I'm happy that's done. There's only one more hole to drill with this bit, and that's going to be the hole for the Z-axis plate on the very top of the machine. Another great tip for cleaning up oil stains like this one is to use some acetone, and this is basically just nail polish remover. and you just want to get a little bit on your kitchen towel or whatever you want to use, and that'll wipe that oil straight off. As you can see, really helps. Be careful not to inhale too much of this stuff, it's not really great for you. So again, let's use a little bit more, hopefully get a better wipe on this one. There we go, that's that side clean. Let's do the other side. It's worth doing this even if you are going to be sanding these down, because you don't want any oil getting on your sanding discs either, because that's just going to cause more issues. So as I said, deburring tool is very useful, and these are great for exactly holes like this where, like I said, we can't really get a countersink bit big enough. I mean, they do exist out there, but probably very expensive and you don't really need it. So what you can do is just use these and make your way around the edge like this. Just start going around. And you'll start to get a nice chamfer there. That's all you want, just to get rid of the burrs. You can do the same on the other side. You can see that's nice and smooth now. Same on this side too. It can be a little tricky to get going at first. Keep at it. You see, just keep going. There we go. That's that one as well. Nice and smooth. Happy days. So what I'll do now as well is I'll do the other taps on here. As you could probably tell, I made one mistake on here, which was using a 5mm bit for that hole when it should have been a 4mm bit. The reason for that is that these need to be 5mm or M5 threads, sorry. It's not the end of the world. I can just turn that into an M6 thread and drill out a larger hole on the motor itself. But just be aware of that. When you're drilling so many holes on one piece, you want to be triple checking yourself with your bit. Sometimes it's easy to make that mistake. As I said, it's not the end of the world in this case. I'll just turn it into a larger thread. Okay, so here we go, exciting stuff. I've got either end of the gantry plates done, as you can see, bolted to the bearing blocks. I have all the holes marked out and drilled. All we have left to do in terms of the main structure of the frame now is get the holes drilled in the edges of this back plate. Once again, as you've seen repeatedly throughout this build process, because we already have these holes drilled here, we can use them to mark up our holes either side. So what I'll be looking to do now is take this large back plate, line these pieces up like this, get my markings, drill out the holes which these will then bolt to, and we'll have our gantry set up. There we go. This is starting to look truly awesome now. So this is going to be a big heavy gantry, but it's going to be strong. Like I said, we got that 20mm plate either side. Both of the linear rails are connected to the same back plate, so you're not going to get any movement there in terms of the machine. And it's rigid, solid as a rock. So what I'm going to do now, like I said, if I bring you around the side here, you can see the way I've got this lined up, exactly like before. I'm going to create a clamping system that will allow me to clamp this to this. It's a little difficult because I'd like to clamp it this way, but obviously these parts are of different lengths. So what I'm going to do is take a block like this one, cut it down to size, make sure it is of equivalent length to the whole plate. That will then allow me to clamp this whole section to the back plate, which will hold it perfectly in place. That way I can then go and drill the holes just like I did before, and we should get very accurate holes. So like I've said throughout the video, when you're making your alignments here, try to avoid using wood or anything that could potentially warp as your back surface to get everything in line. So these are two remaining plates. So this is the motor bracket plate, and that's the Z-axis back plate. I know these are perfectly flat, so when it comes to doing my alignment here, I know that that's going to sit truly flat there on both the surfaces, so that when I do my holes, that'll be a lot more accurate when it comes to drilling the holes, and when I bolt them back on, it'll sit nice and flush. The problem with using wood, especially something like OSB, is it's very bumpy and it's not flat. So you wouldn't want to use that as a reference, because it's likely going to make your measurements wrong. So I've got another piece of material here, which is one of the bearing block standoffs for the Z-axis. But again, we can use these parts to assist us in lining everything up. So I know that this back surface here now is perfectly flat. I can use this to make sure that these meet here perfectly flat, and I know that's correct. And like I said, what I've got is a piece of wood that I've cut to size that I can place here, and that is of exact length from top to bottom here. So if I go and get a clamp now, one of the things I can quickly achieve here is a nice jig. So if I start to clamp this together, you can see if I line that up here with the block of wood in there as well, start to squeeze it together, just sort of get it firm first of all, push everything in together tightly. So this does require a bit of patience just to get everything the way you truly want it. Like I said, if you just pinch it initially, that'll hold it in place, and then you can make sure that everything is nice and flat. In this case, that's perfect. This is in line at the bottom here, so I can squeeze it in. Okay, so if I zoom in there, you can see we've got a pretty decent jig now. This is all parallel with the top of the back plate and the top of the side plate. This is flat with the back surface. There's a nice join here as well on the side. So just like on these parts, what I can do now is use them to initially start off some 7mm drill holes, because obviously we're going to do an M8 tap on the sides there. I will be using the pillar drill to do the holes. Like I said, I'm going to have to get a bit creative with the pillar drill, because this is such a long part that it's obviously not going to fit underneath the drill itself, so I'll have to come up with a better method to do that. So now I can take this, head over to the pillar drill, take my marked holes here and drill them out. Okay, so as I said before, when you have limited tools in your workshop, you have to start getting creative, and that's what I've tried to do here. So you can see I've got my benchtop pillar drill, and I've effectively turned this on the side here so that we're overhanging the bench, and I have the pillar drill right on the edge of the bench here. And basically this is going to allow me to drill larger objects like this that are not going to fit under my benchtop drill. Now if you've got a floor standing pillar drill, that's great, use that. The problem is a good one of them is going to set you back about $1,000, and I don't need one of those in my workshop. It's not worth it for me to purchase one because I won't use it enough. However, I do need to drill these holes, so this is how I'm going to do it. So all I've done here is I've stacked this up to the correct height, and your first step is to make sure that this itself is level. That'll make sure that your workpiece here isn't sort of swaying out to the left or the right. You're going to be drilling perfectly straight that way. I've checked that already, it's all great. Now what I've done is I've secured a spirit level to the back plate here, and that's going to allow me to look at this here and determine whether we're straight or not. So to ensure that we're always going to be level, what I've done is I've put the pillar drill on top of a spare piece of OSB here, and I've clamped it down. So you can move the OSB forwards and backwards till you find the right spot. I'm also doing it against one of my legs here for the bench. So I know that when this is touching that back surface, based on the bottom position, that this is straight. Then what I can do is move the entire pillar drill around to get the correct position to do the holes. So before we were moving the workpiece around to line up with the bit. This time we're moving the whole tool around to be in line with the hole. And that's the only way you're going to get around this in terms of working on large scale pieces like this on such a small drill. This isn't an ideal setup, but when you're limited and you need to get those holes drilled, this way is better than doing them by hand. If you do them by hand, you could probably get pretty close, but I don't want to take any chances here because this piece of stock material is expensive. It's the biggest, heaviest piece that I've bought, and you don't really want to mess these up. So you only get one shot at doing these. So I need to make sure that they're correct, and this is how I'm going to do it. So when realigning these back up, what I find the best way to do it is I tapped 2 of the holes and I've secured 1 bolt here. That allows you to line everything up perfectly. So this back surface here is perfectly flush with this side plate, and so is the top. So now that I've got that one locked in, I'm going to place in a second bolt and tighten that up. And you can see I marked up which ones I was starting with there so I could tap them. And it's also a good way to reference the orientation because it's easy to get mixed up. You wouldn't want to put this on the wrong side, or you wouldn't want to put it inverted, if that makes sense. So with these 2 bolts then in place, I will proceed to do the other taps. And by tapping while bolted in place, you know that you've got your exact position. Because if you do all the taps before putting this in place, you're then trying to realign all the bolts with the holes. While you try to do your drilling as accurately as possible, as I've said throughout this entire series, there's human error, it's going to happen. If your drill isn't very good quality, chances are the bit's going to move around a bit. So with these bolted in, you can set your position so that you're happy, so that everything's flat and square, and then from there you can do your other taps whilst it's bolted in place. So that's what I'm going to do. Okay guys, so here we are. We have the gantry assembled and situated on top of the y-axis here. Unfortunately, I did lose about 1.5 hours of footage due to an SD card error, which is a shame, but you won't miss too much. Basically, I was bolting the right side on here and I lost all of the footage of me drilling, tapping and bolting the left side. But it's the exact same process, so you haven't missed too much. Unfortunately, these things do happen, and I'm grateful in all honesty that it wasn't a lot of the other footage that I've managed to save. But moving on, you can see this thing now is really starting to demonstrate what it's going to be capable of. You know, this is 20mm thick gantry plate here. Both rails are going to be connected on the same back plate, which is going to eliminate flex. It's just going to be such an awesome machine, and I'm really excited about it. And again, you look at what else is out there for this price point and you will not find anything with a frame like this. You just will not. So it goes to show what you can do if you're willing to put in your own time and effort to create your own machine. And it's not that difficult, honestly. You've seen that already. As long as you can measure and square everything up, it's pretty straightforward. And I hope that these videos are conveying that if you're not feeling so confident in using these kind of tools and stuff, remember this is my first time using a lot of this tooling as well, particularly on metal work like aluminium, and I've managed to do it. Everything's great, so it's going to be really exciting. Next steps from this video now are going to be getting the y-axis rails bolted down on here, and I'll also attempt to do the x-axis rails as well. I will need to assemble the z-axis in order to do that, because just like the y-axis here, where we're going to use it as a jig to line up the rails. I'll use the Z axis as a jig to line up the X rails. That way we'll have everything perfectly parallel. It's super exciting. I'm loving how this is starting to look. It's truly looking like a real CNC now. We're going to gain some significant height here because obviously we've still got the rail to put on, and we've got these big bearing blocks as well, which are going to sit here. So you know, we're going to gain considerable height here on the gantry. I've ensured here that there's plenty of room for a spoil board and plenty of Z travel on the spindle also. So if you made it up to this point, thanks for watching. One other thing before you go is, if you haven't seen my last YouTube upload about the Discord community, go and check that out. So what I've done is I've opened up my members only Discord community to everybody. And the reason I've done that is to get more discussion in there and just get more people involved in building a community of like-minded people. So if you've got any questions about this, you can ask them in there. I can answer them, other people can answer them, and the idea is we can all help each other out. I've also released photos of this prior to making this video, so if you want to get earlier updates, it's great for that as well. As always, thank you so much for watching. I hope you learned something. Thanks for your time, and I'll see you in the next video.